Hey everyone, ready to dive into something pretty cool?
Always.
Awesome. So we're taking a look at this article from the Continuous Improvement blog.
Okay.
Came out January 15th of this year, all about supercharging data processing, with something called grid stride loops in CUDA.
Interesting.
I know, right? And you know how much data we're all dealing with these days?
Oh, yeah. It's insane.
It's crazy. So squeezing every ounce of performance, from our hardware, that's becoming more and more crucial.
Right.
And that's where, of course, GPUs and CUDA come in.
Exactly.
So this deep dive, what we're going to do is unpack what grid stride loops are, how they work, and why they're so beneficial.
Sounds good. I'm excited.
Yeah. Plus, we'll even look at a cool example of calculating hypotenuses, for a ton of numbers.
Wow.
No, it's wild. Okay, so the article calls these things grid stride loops. Can you break that down a little for us?
Yeah.
What are we actually talking about here?
Well, think of it like, like a design pattern.
Yeah.
Like a blueprint, for solving a problem.
Gotcha.
In CUU.
In CUDA. Yeah.
And in this case, the problem is, how do we process tons of data?
Right. Right.
Like efficiently, right?
Right.
Using all that parallel power of a GPU.
Yeah. Yeah.
And so instead of having each thread, work on one data element at a time, grid stride loops let threads iterate over multiple elements.
So it's a lot more efficient then, especially for large data sets.
Yeah, much more efficient.
So instead of going one by one, we can have multiple threads working on multiple pieces of data at the same time.
Exactly.
Was that the gist?
That's the idea.
Okay, cool.
Yeah, and to understand how it works, we need to kind of know a bit about how CUD is structured.
Okay, yeah. Let's do that.
So you have these threads, and they're organized into blocks.
Okay.
And then those blocks together, they form a grid.
Threads, blocks, grid.
Right.
Got it.
And each thread has this unique index, right? It's kind of like an ID number.
Okay.
That tells it where it sits within that grid.
Okay, I'm following so far. Threads, blocks, grid. Got it.
Perfect.
But where does the stride come in?
Good question. So the stride is basically the total number of threads in the entire grid.
Okay.
And each thread will process elements at intervals that are defined by this stride.
Interesting.
Yeah, so if you have a stride of, let's say, 100, each thread would process every 100th element in your data set.
Ah, I see. So each thread, it uses its own unique ID to know which data to grab.
Yeah, the unique thread index. Exactly.
Pretty clever.
Yeah, it's a really neat way to ensure that the data is processed in parallel without any overlap or any missed elements.
Yeah, and it seems like a much more systematic way to, divide and conquer that workload.
Absolutely.
Now, the article even had a visual representation of this with threads sort of like leapfrogging over each other to grab those data points. And that visual really, helped me understand it.
Yeah, it's a great visual. It captures the essence of grid stride loops.
Totally. And, it feels so much more efficient than having each thread just kind of trudge along one element at a time.
Absolutely, and it highlights a very critical aspect of GPU performance, memory access.
Oh, right. They mentioned something about memory coalescing. Is that related to how the threads are accessing data?
It is.
Yeah,
right. So imagine like a group of friends.
Okay.
All trying to grab snacks from a bowl, right?
Yeah.
If they all just reach in at the same time,
it's chaos.
It's just chaos.
Yeah.
Right? It's much faster if they take turns.
Yeah, way less chaotic, and they get their snacks faster.
Exactly right. Well, the same principle applies to threads accessing memory on the GPU.
Interesting.
When threads access memory in this, scattered, unorganized way, it can really slow things down.
Oh, okay.
But with grid stride loops, the threads are accessing memory in a very structured and predictable pattern.
So the grid stride helps organize the threads, so they're not all trying to grab the same piece of data at the same time?
Precisely. And this organized access, that's what we call memory coalescing.
Oh, okay.
And it's a key reason why grid stride loops are so efficient.
It makes a lot of sense.
Yeah. So coalesced memory access can be up to 10 times faster than uncoalesced access.
Wow, 10 times faster.
Yeah, it's a big difference.
That's huge.
It is.
Okay, so now I'm really starting to see the appeal of this whole technique,
Right.
We've got this parallel processing, we've got efficient memory access. Seems pretty intuitive to understand, too.
Yeah.
What else makes grid stride loops so great?
Well, there are definitely a few other things. Well, another major advantage is flexibility.
Okay.
You could use grid stride loops for data sets of any size.
Oh, wow.
Big or small, doesn't matter.
So you're saying it adapts to the data?
Exactly.
No more fiddling around trying to find, the perfect settings.
Exactly.
Meet this nice.
It just works.
Okay.
You write your CDA kernel once,
Mm-hmm.
and it gracefully handles data sets of, 1,000 elements.
Right.
Or 1,000,000,000. That flexibility saves you time.
Yeah.
And makes your code much more versatile.
That's super handy.
It is.
I've definitely spent my fair share of time tweaking grid and block settings in the past.
I think we all have.
Yeah, it can be a real pain.
And speaking of large data sets, grid stride loops also excel at scalability.
Oh.
As your data sets grow, you don't need to rewrite your code.
That's good.
You simply scale up the grid.
Oh, okay.
By adding more threads and blocks to match the increased workload.
Okay.
This way you can fully utilize the power of your GPU and keep those processing times low, even when dealing with massive data sets.
Okay, so we've got flexibility, efficiency with memory access, and scalability.
Right.
All great things.
Mm-hmm.
Sounds like grid stride loops are a powerful tool for anyone working with large data sets.
You certainly are.
Yeah.
And the article does a great job of illustrating this with a practical example.
Okay.
They demonstrate how to use grid stride loops to efficiently calculate the hypotenuse
Right.
for 1,000,000 pairs of numbers.
The hypotenuse example. I was curious about that.
Yeah.
Can I walk me through how that works?
Of course.
I remember the concept from, geometry class, but
Sure.
I'm a little fuzzy on the details.
So imagine you have 2 large arrays, each containing 1,000,000 random numbers.
Okay.
And you want to calculate the hypotenuse for each corresponding pair of numbers from these arrays.
Okay.
With a grid stride loop, each thread in your CUDA kernel can grab a pair of numbers, perform the calculation using the Pythagorean theorem,
Right.
and then store the result.
Okay.
Even with 1,000,000 calculations, a well-designed grid stride loop can help the GPU handle this in a flash.
So even though we're dealing with a ton of numbers,
Yeah.
the GPU can churn through those calculations incredibly quickly.
Very quickly.
Thanks to the parallel processing power of the grid stride loop.
That's right.
That's impressive.
It is.
The example also highlights how concise and readable the code can be, even if you're not a CUDA expert. The article provides a snippet that demonstrates the core steps,
Right.
importing the necessary libraries, initializing the data, transferring it to the GPU, launching the kernel, and retrieving the results.
Yep, all the key parts.
It's great that they show how this all comes together in code without getting bogged down in the, complexities.
Absolutely.
Now, while this hypotenuse example is a good illustration,
Yeah.
remember that grid stride loops are not limited to just this type of calculation.
Right. Definitely not.
They can be applied to a wide range of problems that involve crunching large amounts of data.
Exactly.
So what other kinds of tasks could benefit from grid stride loops?
Oh, tons.
The article mentioned a few, but I'm curious to hear your perspective on this.
Okay, sure.
What are some real-world scenarios where these loops could really shine?
Well, the possibilities are vast.
Yeah.
Any field that involves processing large data sets
Right.
could benefit from this technique.
Okay.
Take image and video processing, for example. You might be performing operations on millions of pixels
Right.
to enhance images, detect objects, or apply filters.
Mm-hmm.
Grid stride loops could significantly accelerate these operations,
Okay.
leading to faster processing times and smoother user experiences.
That makes sense. And I imagine scientific simulations could also benefit.
Definitely.
They often involve crunching numbers from huge data sets collected from experiments or sensors.
Absolutely.
Like think about weather forecasting,
Yeah,
climate modeling, or even simulating the behavior of galaxies.
it's true.
These simulations rely on massive amounts of data and complex calculations.
A lot of data.
Grid stride loops could help researchers process this data more efficiently, leading to faster results and deeper insights.
Exactly. It's all about speed and efficiency.
And then there's machine learning, which seems to be using more and more data all the time.
Oh, absolutely.
Right.
Machine learning algorithms, especially deep learning models, they often rely on matrix operations
Right.
and other calculations that can be easily parallelized. Grid stride loops could significantly speed up the training process,
Yeah.
allowing researchers to experiment with larger models and data sets, and ultimately leading to more accurate and powerful AI systems.
It's amazing how this one technique can have such a broad impact across so many different fields.
I know. It's pretty remarkable.
It really emphasizes the importance of understanding parallel processing.
Yes.
Especially as we continue to generate and analyze more and more data.
Couldn't agree more.
Yeah.
And what's really fascinating is that grid stride loops aren't just for CEA experts.
Oh, that's good.
They're a fundamental building block for anyone who wants to tap into the power of GPUs for high-performance computing.
That's a good point. It's not just about, specialized applications. It's
Yeah.
about a fundamental shift in how we approach computing in general.
Exactly.
Yeah.
As GPUs become even more powerful and accessible,
Right.
and as we continue to grapple with ever larger data sets,
Mm-hmm.
techniques like grid stride loops will only become more important. It's like learning a new language for the future of computing.
It's like we're unlocking a secret level of understanding.
I like that.
But we've covered a lot of ground here. We've talked about what grid stride loops are, how they work, the key benefits, and even explored some potential applications.
It's been a good overview.
It has. Do you think this technique will become as commonplace as using a for loop in programming?
That's a good question.
Will everyone be using grid stride loops in the future?
It's tough to say for sure,
Yeah.
but I do think that as GPUs become more integrated into our computing,
Right.
techniques like grid stride loops
Mhm.
will become
Yeah.
increasingly important tools for us to have.
Okay.
It's all about adapting to the changing demands of,
Right.
data processing
Right.
and harnessing that power of parallel computing.
Yeah. It makes sense if we want to keep pushing those boundaries, of what's possible with data.
Right.
We need to find ways to make our code more efficient and scalable.
Absolutely.
And grid stride loops just seem to fit that perfectly.
They really do. And remember,
Yeah.
this is just the beginning of the exploration.
Right.
We talked about memory coalescing,
Yeah.
but there's a whole world of optimization techniques within that.
Oh, for sure.
We've only scratched the surface of potential applications.
Oh, yeah. And I'm already thinking about all sorts of possibilities,
Yeah.
Beyond the examples we talked
Yeah.
about. What about using grid stride loops for signal processing, financial modeling, or even cryptography?
Those are great examples.
Yeah.
Where parallel processing could offer huge benefits.
Right.
The key takeaway here is that grid stride loops aren't just about specific applications.
Yeah.
They're about a fundamental shift in how we think about computation.
Right.
It's about embracing that power of parallel thinking and finding those creative ways to leverage
Yeah.
those massive capabilities of GPUs.
I love that. Think in parallel. It's a great mantra for anyone working with data in this age of GPUs.
Exactly.
This deep dive has really given me a solid foundation.
Awesome. Glad to hear it.
We went from, what is a grid stride loop to understanding how they work, why they're beneficial, and even glimpse their potential across all these different fields.
It's been quite a journey.
It really has.
And the most exciting part is there's so much more to discover.
Oh, yeah.
So, to our listener out there, if this deep dive has sparked your curiosity,
Right.
don't stop here.
Yeah.
Keep digging deeper.
Keep learning.
Experiment with different applications
Yeah.
and keep pushing those boundaries of what's possible with parallel processing. Who knows? Maybe you'll uncover new insights and applications that haven't even been explored yet.
That's a fantastic challenge to leave our listener with.
There you go.
Thanks for joining us on this exploration of CUDA and grid stride loops.
It's been a pleasure.
Until next time, keep exploring, keep learning, and keep diving deep.